So what I'm going to do, and it's going to be easiest to go this way, so I'm going to ask you, Sima, to introduce yourself.
All right. Hi, I'm Sima Sethumadhavan. I'm a faculty member in the computer science department at Columbia University, and also founded a company called ChipScan. At Columbia, a lot of my research is on how to improve computer architecture to improve computer security, and computer security to improve computer architecture and computer design in general. So that's been my main focus, and I've been doing this for about 15 years now.
Okay, Kaylee.
Hi, Kaylee Rice. I'm our VP of Strategic R&D at Leidos for our defense systems sector. And what that really amounts to is trying to address the valley of death and find the best and most relevant R&D projects and other companies and internal projects to pull through into our systems and really bring out into the world.
Yolanda.
Hello, my name is Yolanda Reed. I am at IBM. I'm Associate Partner for Cybersecurity and Microelectronics. In my current role, my job is to listen to the federal clients and to try to do consulting for them, to give them best technical solutions for their problems, regardless of vendor, and really client focused on their issues for today and tomorrow.
Margaret.
Hello, everyone. My name is Margaret Schmidt. I've been in semiconductor innovation for more than 25 years, advancing solutions and solving challenges in the area of advanced computing, 5G, mobile systems, and AI.
Hello, everyone. My name is Mark Taranapur. Done a little bit of work in domain of hardware security over the past, 20 years. Multiple hats, professor. I wasn't happy, so I decided to become chair and go into administrative, which I found it very challenging. Don't do that if you want to keep your sanity check. And also co-founder of a company called Caspio Technologies. Caspio provide actually EDA solutions to secure designs. We have all sorts of solutions now commercially available, and we can be more thankful to our customers finding the solutions useful to them.
Okay, thank you. Well, thank you for those intros. As you can see here, quite a background in security here. So on that basis, let's go with the first question, which is, there's lots and lots of attacks we hear about all the time. I get press releases every day on the latest NHS attack in the UK or the latest wherever. What is the current state of security, and what are you seeing? Maybe we start with you, Mark.
Sure. So I think the biggest challenge I see is that because we're talking about chips and systems, they're becoming more complex by the day, and as a result, if you leave security aside, we have actually too many bugs already in the designs, right? So you probably hear that company X, say Intel, ships some of the products with actually known bugs in their system, right? Why? Because time to market matters, all right? So as a result, if you have systems that go out with that kind of a bug, you should expect that there are security bugs. And as a result, you get a smart people like Simha, right, as an opportunity to be able to break into it and then identify some of those issues, because really the designers don't have time to address those challenging problems. So my opinion, I can give all sorts of reasons why this is a problem. My point is complexity and time to market. We're living in a market where NVIDIA CEO just announced that their cadence now is basically 1 year. Every year they're supposed to be shipping new chip. And if you do that, that means you're going to leave a lot of security bugs in the system.
That's a problem. Yolanda.
I would like to add on to what you said. I think for such a long time, people just trust that hardware is secure, and we've been focused on software for so long. So there's an education that needs to happen to say that there are vulnerabilities, and we accepted this for a little too long. And while we're talking about it, our adversaries are already exploiting it.
That's true. I mean, you talked about time to market, but then you can't really plan for everything, every eventuality. So I think it's a big challenge for the consumers, the manufacturers as well. Margaret.
And Nitin, I'd have to say, no, we are not winning this war. We are losing this war. If we look at the historical trend of vulnerabilities recorded, we see that the speed and sophisticated attacks is outpacing our solutions and our defenses today. And we're this community, we have point solutions at the front end of the chip design. We have solutions at the back end of the system deployment, but that overarching solution that helps us not react to attacks. As you've highlighted, identifying attacks, reacting to that, but predicting and outpacing our adversaries. This is a challenge for this community.
I think, I don't know who said it, was somebody talked about system level thinking, which is looking at all the little holes. But
Yes.
Kaylee, on challenges, on state of security.
So being sort of the representative up here from the defense industry, we have a slightly different problem than commercial companies. We do have a time to market problem in defense generally, but it's not quite the same as for the commercial companies. I think that there's a huge problem just with the understanding and with the available workforce to be able to address some of these problems. Fundamentally, you only have to break into a chip once, but to defend it, you have to defend against everything. And so it's almost impossible to do that, really. And we need to find some alternative strategies to do well enough, quickly enough, and get enough automation and enough tools that are going to help fix that workforce problem. We might have people who are great at designing, missiles and tanks and airplanes, or people who are great at writing software, or people who are great at writing, designing the hardware. But then you layer security through that whole thing, and very few people are going to be available to do that kind of work.
Yeah, you just give me an image of Die Hard 4, the tornado, and somebody hacking into it.
I think strangely enough, software security has actually improved quite a bit in the last 10 to 15 years. And if you look at modern exploit chains, hardware actually prominently features in some of them, the more advanced ones. So I think it's already happening that hardware vulnerabilities are being exploited and used in exploit chains. And especially things like, things that support software security. Hardware that supports software security are the things that are being attacked. So there is security of the chip design itself, but then there are things that we put in to help software that are also being targeted and attacked and being exploited. And as Mark said, systems are becoming very complicated. We don't actually have enough people to work on security. That's a big issue. The other big thing is the layers and layers of abstraction that systems are built on right now. And nobody actually understands things in a vertically integrated fashion, and the misunderstanding of abstractions is one of the biggest challenges, I think, in trying to secure systems.
And with those, sorry, Yolanda, go on.
And I wanted to add on to what these two have said. In defense, and I spent a background of 21 years as a civilian before coming in industry. There's so many things to pay attention to, so many missions that are happening at this very same time. And so with chips, when you say security of microelectronics, where do you start? If you take that plane, there's so many aspects of that plane and everything has a chip. So we almost need to prioritize where we need to focus, and it's just so many different chips. Obviously, you want to think of things that are using AI, right? That's thinking for the machine. You want to prioritize that. But then if you look at this light bulb, if you have a smart light bulb in any of the plane, they have chips too, and they're not always being used for the right thing. So there's so many aspects to this problem. And I hope that industry can help partner with governments for those things, because it's a lot. It's overwhelming when you think about it.
Yeah, I think that is actually going to be a key thing. Even, you talk about defense, but even in my home, where I see all the stuff, and I'm so conscious of, somebody spying on it through there or whatever, through the light bulb or something. Mm-hmm. And it's been going on for some time. So, I think you all alluded to one of the challenges. We're going to talk about challenges, and one of them, and I hear this all the time in the embedded systems world, is not enough embedded systems engineers and developers, but then also I hear not enough skills to understand the security. So, that's one of them, I guess. Anybody want to elaborate on that? Any other challenges? Okay. Okay.
Yeah, I mean, we have some academics on the call, right? So it really, look, workforce is easy to say, well, we don't have enough people, but let's be honest, right? I say it's government's fault and industry's fault because they're not willing to spend as much money that is needed on security. Because if you do, then you need more people. And if you need more people, we will produce it for you, right? I can't produce a lot of students if you're not asking for them. Now, don't get me wrong. I mean, our students do very well. They get 5 offers before they graduate. But we're talking about a community that produces those students, right? We hear all the time about cybersecurity is important and shortage of cybersecurity, right? But you go to any of these companies and ask them, are you spending enough on it? They all give you all sorts of excuses as to why not, right? So I think there is a catch-22 here, that we can't just produce when there's no demand. Right?
But there's no right amount either in terms of spending.
For sure. Yeah.
So I think this is a key element where academics and industry and government should be collaborating, and I think that we're starting to see some of that in the general industry, and some of that a little bit more specifically focused on security as well. There are some programs I know in Indiana. There are some. There's a number of universities that I see all over the place. In the same room as government folks, and there's people from AFRL and from Crane and from OSD at a lot of events too, and there is some funding going into those programs. Sure. So I think we're starting to see more awareness, we're starting to see more take-up of this topic, but it's kind of incumbent on all of us to make that happen across all of our respective sectors.
Yeah. So if I can build on what Mark said, people like Mark have been teaching like a lot of hardware security for a long time. I think if you view this as a pipeline, the early stage of the pipeline I think is well sourced right now. There is definitely head of line blocking because I think people at the top are not incentivized sufficiently to think about security proactively. Mm-hmm. And then the middle management, yes, there is still a problem, but what I'm hoping is that the students right now who are taking jobs, when they actually become project managers, they'll think about security because of their education.
So it's feeding into the pipeline
It's feeding into the pipeline from the bottom up. Yeah. So I'm a little bit positive in terms of outlook, in terms of the middle management. But at the high level, I completely agree with Mark that there needs to be incentives put into place for security to be adopted.
Yep.
I would just lay on to this. Maybe I'll speak for the voice of the chip designers and design managers in the audience. Completely agree with the comments here. The pipeline's building. We need more government support, more investment in security. Absolutely, and academic programs are building. But I need to take my chip out now. Yeah. I need to determine how does security fit into my design flow? Where is it fitting in? With verification, with timing, with power. How much will this cost me? And now my team, I don't have an SOC security team. That pipeline hasn't reached me yet. So what are the tools? How do I get my team up to speed? I've got a great team. How do I empower them? And that's where I think we're going to see a lot of AI support come in to help accelerate that ramp to get my team up to speed while we're building that pipe.
I mean, I think all the people I've interviewed this week alone, they talk about the AI being used as tools to help people who don't have the skills. So exactly. It's to that point, I guess. Any other challenges? I mean, we talked about talent and skills. Are there any other big challenges, Katie?
Yeah, so I think one, and actually you alluded to it, that the people at the top don't have the incentives to put.
Okay, yeah.
So I think connected to that is the understanding. So a lot of people at the top, whether you're talking government or industry, aren't necessarily hardware designers, and they're not necessarily, well-versed in exploits. And it's very hard to explain something that we cannot measure and put into a simple number to flow up. So it's an incredibly challenging problem to figure out how to boil that down into something quantitative to put on an executive level slide. And so I think that is a big challenge in terms of, in some ways, selling the value of the security work that we want to be able to put into things.
I think on the challenges, we're going to talk about regulatory landscape later, but on that point, there's in Europe, we've got the CRA, the Cyber Resilience Act, that's come in, and it's basically going to have an implication in terms of big fines if you don't have security in your products, any products that be supplied into Europe. So anything developed in the US, in Asia. So I think, could that be that incentive or that stick?
Yeah, I think when you think about governments forcing security, you can think about sticks, or you can think about carrots. Like the punishment, I don't know if that's the right way to go about doing things. It is, if you think about it, in real life, when criminals conduct bad activity, we punish the criminals, we don't punish the victims, right? So if the companies generally, I think, are trying to do their best efforts to implement security, punishing them is not a good idea. Right. Okay. So what I do think we need to do is there's this problem of metrics, right? Like, give me a number. Security is fundamentally irreducible. It's not a quantitative thing you can do. So trying to produce a number, I don't think is the right way to do it. Yeah. But to enable innovation and proactive thinking in security, I think what the government needs to do is step in and create the disincentives right now for security to companies, which is there's a first mover disadvantage right now. If you are the first company doing security, you are taking a hit in terms of power, performance, time to market, etc. There is no incentive for you to be the first mover and do poorly on security. So if the government can step in and say, create a level playing field, say everybody must devote a certain level of effort towards security. Say 15% of your budget, 30% of your budget, whatever that number might be, we can figure out what that number is. That must be dedicated towards security. I think that'll create a level playing field and try to move things forward. So I think there needs to be innovation in how we think about security regulations, right? We can't just be doing the same punishment. We can be here are a set of 40,000 rules that you have to follow. Checklist security doesn't work, right? So none of those things work. I think we need to kind of create room for security market to take hold.
Okay. I was going to say, if anyone in the audience has questions, feel free to raise your hand. If I see it, then I'll ask you to come up. But any questions so far? No?
I'd like to, can I respond to that?
I know, I think I was, that's why I went to the audience in case there was a response there, but it's actually quite an interesting point.
So I absolutely agree that there's a slippery slope of regulations to say that you have to do certain things, because coming from that industry where we are really requirements driven, there are a lot of flaws in that process, and many of them have to do with the fact that our regulations do not keep up with technology. So if we set a minimum floor of requirements that you must meet and punish people who don't, we will meet those requirements, but they're not going to be the right requirements. Maybe they are, when someone first writes them down, maybe they're not, that's another question. But they certainly won't be the right requirements in 6 months or 6 years. And they're likely to still be the policy in that timeline. So building something more innovative to motivate and to really incentivize people to build security into their systems is going to be a lot more effective in the long run.
What industry view, Margaret?
The good news is we've solved this challenge before. This isn't new. Functional safety, if we think about automotive, aerospace, how did we solve that problem? How did we get the industry and government to align on producing safety-focused systems? And healthcare devices are another great example, with the FDA. So we've been successful. Exactly. We've been successful, and I won't throw numbers out. Yes, I will. ISO 26262, I'm sure that resonates with a lot of people in the audience. Yes, that was a big step for all of us. Learning about it, ramping up the teams on it, the tools, and we don't want to have a bring your own security system, right? Okay, everyone invents their own picture of what security looks like. No, we need an aligned standard. We need a North Star that these systems are all working toward. And we provide safety across not just the hardware device, but the systems themselves and the interfaces. But we've solved this problem before with automotive. We're aligned to this. You go to Germany, you go to Japan, you go to the US.
Yes.
We're all building our systems in alignment with this. Now, yes, this hardware security, cybersecurity challenge is X levels more complicated, but can we apply that?
And it's not all bad news because, I mean, governments around the world are implementing these regulations and rules. So I guess coming to, you're talking about 26262 being adopted, maybe some of these others, I mean, in Europe we've had a few
21434.
Yeah, that one, and then in the US, I think California passed something long ago. So, it's coming, but yeah, I guess it's just a question of time for people to adopt it. Yes? Oh,
Yeah, you want to go for it?
Yolanda, go on.
So to counter or give a different viewpoint, right? I think that coming out with regulations, yes, we might get it wrong in the beginning, but it's good to have a minimum standard because what are we facing right now? Right now, counterfeit chips are everywhere. And do I want that in my national defense systems? No. So there has to be something in between instead of waiting until we come up with this fairy tale regulation that's going to meet everybody's requirement. I think there are some bare minimums, right? If you said this chip's going to do this, it should do that. Right? That's a really bare minimum requirement. There's standards out there that we can adopt and we can agree across the nations to start with. So I think there's things we should start with. It's just we won't get the whole thing right in the beginning.
So for me, look, context matters, right? So when you think about regulation in a, let's say, manufacturing process, right? So let's say, think about automotive applications, you have the zero defect or zero DPPM requirement, right? And makes sense. Well, the reason that makes sense is because defects are modelable. Okay, let me use that term. How could you model the intelligence of an individual that know that he can actually break into a system that you don't know when? So good try. I would say stay away from regulation. Yeah, requirements are different than regulations. Okay? My opinion is let the market actually dictate what needs to be done. Did we say that somebody has to offer a zero defect solution for automotive? No. The automotive company came in and said, we can't afford having somebody in a highway run into an accident that can cause huge problem. Therefore, we need this. So what happens? Well, they pay more because the companies that provide those chips, they're actually testing it a lot more, right? So my opinion, security at this point, even though I sell security, hasn't been basically elevated to a point that we do have these examples so that these sort of requirements come from industry. Look, ISO 21434 is a good example. A lot of companies that we talk with through Caspio Technologies, they actually point to that because they want to have, they are being asked by automotive companies to be compliant with this ISO standard, right? Let the industry decide what's best and what works. I said context matter because you mentioned about counterfeit. When you put regulation doesn't also address majority of the security problems that are because of human error and bad design. What does have to do with regulation? The reason that you find a lot of flaws, not because there was a regulation, it was somebody else's fault to leave that vulnerability. However, regulation helps when it comes to supply chain. I do think that it actually has a major impact because it's not just a hardware security problem, it's a national security problem. You do need to have regulations in place to prepare you for those disastrous situations like the shortage of the chip during COVID, etc., to help you out, to minimize, for example, infiltration of bad parts to come into the systems, etc. You know, government requires devs to be able to actually provide chips that are being tested because if those chips get into $100 million missile, and if something happens, then they come after you. Obviously in a very soft manner, but you know what I mean, right? So they will hold you responsible, right? So I think those make a huge difference. But when it comes to market and commercial world, I do think that the commercial world has to decide what works best for them.
Although, and we're going to talk about AI later, but just imagine AI in control of that missile.
That is correct.
Any questions? I think, no? Let's talk a little bit about the industry adoption. Obviously, there's lots of different varying approaches, and Margaret, I've spoken to you this year, but what does it take to get the solutions into the mainstream? I think we've touched a little bit on parts of it, which is the standards, the regulation, but from a technology point of view?
Absolutely. And of course, speaking from the voice of this community for semiconductor design, any new flow, any new analysis that we're bringing in has to lower the barrier of entry for design engineers to be using. It's got to be easy to deploy, to use, and to manage in the semiconductor design flow. And that's the perspective we've taken at Amida Technology Solutions, is we're engaging with chip design companies who know they need to make this part of their design flow. And as Dr. Taranapur highlighted, no, this is something they need to do because they're producing healthcare devices, because they're producing systems which are involved in security with defense or safety with automotive. And lowering that barrier, Nitin, I wish I was making this up, but honestly, this is nothing new. Any new simulation technology that you're bringing into the engineering design flow has to lower the barrier to adoption.
Yeah.
So very important point, by the way. It's really perhaps the most difficult part of being in an academia. Develop some of the coolest solutions, but you really don't pay attention necessarily how much of an area or performance of this and that. You do, but not as much. But what's really we don't pay attention sometimes is the cost. So in Caspia Technology, we went through a 6 month of market assessment. I'll share some data of what we did. We went through a 6 month of market assessment. We talked to many semiconductor companies because we wanted to know how much money they're actually willing to spend on security. Because I can give them the best solutions, but they don't want it because either it's intrusive or costly, okay? So we went through assessment of the verification market. I think many of you, if not all of you, know verification market, when it comes to RTL level verification market, is about $1.2 billion today. And if you add emulators, that's actually add another $1 billion to that. So we're looking at $2 billion verification. We talk to any company, we ask them how much of that $2 billion you're willing to pay for security. The numbers varied between 5% to 15%. And Sima, you're very, very close to that number. So we got an average after talking to many that we realized that really companies are not willing to take up more than 10% actually cost for their security. Why? Because everything else matters. Power matters, okay? We're not gonna compromise on those. Security still is not necessarily being viewed as the most important thing to address. So our approach in Caspia was very clear from there. We are going to give you a solution that is not going to cost you more than 10% of your total verification cost. So to your point, Margaret, I think you're absolutely right. There is the solutions to be able to transition from world of R&D, academics, etc., really has to pay attention. I know this may not be applicable to devs because we are spending a lot of our time in the commercial world. That number perhaps could be a little bit higher because of the criticality of some of the applications that you have to deal with. But we deal with a lot of commercial world, and we basically want to make sure the solutions are as low cost as possible to get in. As a result, Caspia's focus was cost-oriented solutions.
Yeah, so
Simon.
if I may add to that,
Yeah.
I completely agree with Mark that academia produces a lot of cool solutions, but they don't actually focus too much on the cost. Power is measurable, area is measurable, and if you kind of focus on those metrics, formal verification is a great thing. It doesn't add to power, it doesn't add to runtime area, etc. Right? Mm-hmm. But if you require like a mathematics PhD to kind of 6 people to work on a team to prove like one specific property about the design that may or may not be security relevant, but it's called security relevant, it's just not a scalable solution, right? So I think like there is a lot of conflation as formal verification as a solution to security. Yeah. I think people need to kind of understand that these are very different things that they're proving, that formal verification may not be the right tool for security. So from an academic perspective, that's what I would offer, so if you kind of take formal verification from this particular part. There's a lot of innovative solutions out there that can be applied today that can significantly introduce security. It's just that we try to push everything through formal verification. I want proof that something doesn't happen. Guess what? You can never get the proof because formal verification has axioms built into it. Attackers attack those axioms. That's where security breaks, right? So that's kind of like, the fundamental thing that we've been doing this for 30 years. It hasn't improved security. We continue doing this. It's like the 99% solution. I'm 99% there, right? I have only 1% left that's not formally verified. But you know what? That's going to cost me the next 99% of the budget.
Yeah.
And you keep doing this repeatedly over and over again, you never finish getting security. So
It's never ending.
I would absolutely completely agree. And as long as you're focusing on those solutions, you're always going to be reactive. You're going to be focusing on what's happened in the past. We're talking about getting ahead of adversaries, predicting what they're going to do, and apprehending those attacks, not just at the chip level. I'm not just talking about running any type of a security analysis on the chip. You've got to protect the chip and the system. That means you're looking at the chip in operation, and you need to be able to pick up those intrusion layers as well. All of this is anticipating, intercepting an attack, and preempting a situation and preventing it. And what I think is truly key, and perhaps my own journey as we've been working on these solutions at Amida, is we can analyze the chip. We can make it more difficult to break in and limit that impact. But ultimately, that chip will be deployed in a system and now a high-value target for an in-field intrusion. How do we detect that? Because we as the industry are responsible not just for the chip. This is a chip to systems conference. We're ultimately responsible for that final system. And what do those solutions look like? Because that's a completely different team, as we all know. Chip team, system.
We talk about approaches. I mean, all the time I've been writing about security, it's all about root of trust. It goes down to the root of trust. I mean, is that the fundamental thing, or is there anything else we should be looking at?
So I think we should be looking at resilience as well,
Okay.
which goes very specifically to Margaret's point. Once you're in a system and you're operating in the world, can you notice when something's going wrong and reset, recover? In a lot of cases, that's enough to just shut down whatever the problem is, whether it's an accidental bug, which that does happen too, because these are very complex systems, or if it's a deliberate attack. But to be able to respond to that almost real time and recover whatever mission functionality you need, in a lot of ways, that's going to be more. I think that's more likely in the long run to really solve that systems level problem than trying to plug every hole in the hardware, in the firmware, in the software along the way.
I would like to add on. I think there's a misconception sometimes with cyber and attacks that, once an actor wants to go after you, it takes milliseconds and it's done. It's usually a process. And so there's many stages that they go through. And once you deploy, if you're looking for those stages, you can actually be resilient. But we need to actually invest in that. And so that's one of those things of education is, are we investing in things that's already deployed, that's already out in the field, that we're already using? Are we still trying to protect them when they're out there?
We didn't discuss this before, but does everything that's going on post-quantum cryptography helped build both that security and that resilience? I don't know, I'm asking the question. Anybody want to take that? No? Okay.
It's a hard question.
Yeah.
I think, and I'll take the stab at it, I think that we're still learning as we're running, right? And so we are developing and we are putting out post-quantum countermeasures, and we're learning. The data is coming on how effective was it worth? Is it something we're investing in now that's going to pay off later? We're still in that learning phase. So give us 6 months, give us a year, and we'll give you a really good answer on that one.
So I think that's really hard to answer until we have quantum computers that we can red team systems with.
Okay.
Right? If you're trying to build something that's resilient to computers that we don't really have, you may be able to design the algorithms that are, mathematically provable in theory. But we know from traditional cryptography that mathematically proven in theory does not mean that there aren't side channels, does not mean that there aren't bad implementations. And so I think until we really have the actual computers that really can break the post-quantum cryptography, or can't, to test against, it's going to be very hard to know how well we're doing.
Okay, well, sorry. Mark,
So on that note, couldn't agree more, by the way. It's not fun that we agree a lot, though, I have to say, on issues. Me too. So we actually prove what you just said. In fact, NIST, when they came down to last 3 algorithms, so we worked with NIST for the past 5-6 years. They reached out to us. My colleague right in the middle, Dr. Farahmand, is sitting there. Actually, she led an effort to break into all 3 of them using side channel. In a matter of 6 months, all 3 of them were broken. So we have a post-quantum crypto algorithm, but already before even coming to the market or being recommended which one is the best, we got back to NIST in 6 months and we showed them that we were able to break all 3 implementation. And these were not our implementation, these were actually performers' implementation on FPGAs.
I think I read about that.
Yeah.
That actually takes us to the next point, and I want to just cover before we finish. Here we talk about AI and generative AI and machine learning. How do you see the security landscape affected by all of this, the AI, generative AI, and I guess it's both a boon as well as a potential threat.
And actually, Nitin, I'll just start off. We're already seeing great applications for AI already in the software cybersecurity world. You're looking at massive amounts of data. AI has clearly proven its value in intrusion detection, as we were mentioning earlier. And there's a direct parallel. We talked about that medical device being deployed in the field, and how are you going to ensure that no one can intrude on that, do a denial of service attack, and otherwise render that device unreliable. So AI clearly, intrusion detection, in-field monitoring, great application. But there's so much more. I mean, inherent strengths of AI for pattern matching, for learning going forward, helping us detect new attacks. We talked about NIST, and we talked about documented attacks that we're now trying to break in. What about the next 10 attacks that aren't in the NIST database that we don't know about? This is where AI can come in and be trained with various types of attack and learn. And my last one is, again, coming back to my engineering team, me, semiconductor manager, engineering manager, knowing that, okay, I've got to do security checks now. Okay, how can we, at Caspia, at Amida, at ChipScan, leverage AI and this powerful tool to help our users have a security solution, again, easy to deploy, manage, and use, and of course scale and continue to learn. So I see that as a huge lever for creating an effective.
That's AI for good, but what about the?
I guess I'll give AI on the bad side, right? With the explosion of AI, everyone's just diving in to use it, but especially at IBM, we're all AI, AI, Gen AI, and AI ML. People don't realize the dangers of AI, so they're deploying these solutions and they're not checking. They're not checking their data. They're not checking their governance. Things are drifting and they're being attacked as well. And so there's a whole ecosystem around making sure that your AI is good. And so a lot of the consulting that we're doing now is in looking at all of those things. How are you securing your data? How are you evaluating you're using good data? Most organizations are not using the right data to make decisions. Data is drifting. AI models are being attack. We have a whole suite of countermeasures already for AI that people aren't even looking at and monitoring. And so there's a lot of dangers to the AI, the infrastructure. So it is a blessing. It's wonderful, but then how do you trust your AI solution? And if you trust it today, how do you know when something happened to it that you shouldn't be trusting it in 3 days or in 2 months? So
I think Sima has a point.
Yeah, I just wanted to build on that. I think that's a really important problem that we have to address, trust in AI. And trust in AI basically can be broken down into a lot of things, including the training data, model deployment, and usage of the AI itself.
yes.
And like at ChipScan, like as Margaret mentioned, I think we've been kind of like thinking about how to use AI ML technologies for security. And what we very quickly realized was that we got to teach the AI security mindset, right? And that's basically a teaching job. Like we are machine teachers in some sense right now. And it kind of gets down to what are the principles we want to teach the machine? What can it generate? What should it not generate? And so on and so forth, right? And then there needs to be safeguards in place. The data that we need to train with, you got to be super careful, right?
Yes.
Like there's a lot of talk about democratization of hardware design, making everything open source and stuff like that. Like what the recent XZ backdoor, I don't know if you guys have been following that, like, this is a nation state adversary who basically worked for 2-3 years to insert a backdoor in the SSH using the zlib library, right? It's kind of a very well-positioned attack. So what is to say that this core or repo out there does not contain a malicious modification? And what if that's used in a microcontroller because it's so cheap and you don't want to pay money for it? What if the AI has been trained on that repo and now generates and mimics that code? Right. There are lots and lots of dangers. I think like the antidote to that is not necessarily just AI. It's, I think, AI plus static analysis tools or logic tools that kind of also go in concert, because we're well beyond the point where a human can look at any of these things and find where the errors are. To avoid AI is a complete mistake. I don't think we should ever do that, because we cannot be making artisanally crafted, handwritten, beautiful Verilog code and stuff like that. It's going to be really bad to do that. So do AI, but actually up your game. Create tools and technologies that can help you design safely in this new era. That I think is what's really important.
Please, Kelly.
So I have a lot of, this would be a great conversation for weeks.
We have 2 minutes. But
2 minutes, okay. I'll try to be quicker than
a few minutes more, I think, we're allowed.
So I think you brought up a tremendous point, and I actually think that this is an area where all of us have brought up good points, but where some of the things defense industry is doing actually are really valuable, because we are very reluctant to throw machine learning at a problem. We don't want everything to be autonomous. You guys don't want all of our stuff to be autonomous. It's a scary prospect. So there is a lot more talk about governments. There are a lot more efforts to build the tools and the frameworks to monitor the machine learning through the whole life cycle of the machine learning, and Leidos in particular has spent a lot of time building a framework for AI resilience and security with different pieces from industry and from our own toolbox and from academics as well, that we can implement in some of these situations. The other point that I just want to foot stomp is the human-machine teaming. The chips, our chip that I worked on is 6 billion gates. There's no way a person can look at 6 billion gates and understand where the vulnerabilities are. So we need the machine learning to do that. We absolutely cannot do it as human beings. But a human being plus a machine is going to be better than either one on their own. And you're going to go astray if you ignore machine learning entirely and are too conservative to make sure that people are doing all the work. But you're also going to maybe go off the rails and insert even more problems if you let the machines do all the work for you. So I think we've seen repeatedly that human-machine teaming aspect is crucial in every kind of application, but I think that's especially true in this one.
Okay. Anyone want to say really pressing on this, or otherwise we'll do a quick summary?
I can summarize actually what everybody said. Basically, you have to talk about AI within context, which is offensive, defensive. The same way that we're using AI to help us identify vulnerabilities and test system corners, the attackers are doing the same thing as well. So AI is not just for us, it's for them.
Yeah.
And also, to Simha's point, AI for security or security for AI, it's the same thing. Again, how do you establish the trust? And considering that we now moving more of the AI hardware and also securing AI hardware is equally important. So how do you secure an AI hardware? Will you use another AI to secure AI hardware, or you have to use human intelligence to do that? It's really a complex problem.
It's a funnel both ways. I'm actually going to ask for you all to summarize what's your key takeaway from this, or what would you like the audience to take away from this? Sima, I'll start with you.
Oh, well, I guess that's a problem with sitting first here. All right, so what do I want the audience to? If there's one thing that you remember from this, remember that security is important. Don't think of it as an afterthought. Think about like designing security from the get-go whenever you design products.
Katie.
I think we said a lot of doom and gloom sorts of things, and I just want to end on kind of a positive note, which is that our goal is not to stop every attack that is conceivable. It's to make it harder, to make it hard enough that we can prevent people from exerting the effort. And I think that is achievable with the tools, the people, and the processes that we've been discussing. We all, the whole community, needs to be involved in making that happen.
Collaboration. Yolanda.
So I would like to end that I think security for hardware is a conversation we should continue to have for a variety of perspectives, from the technology to the regulation to where do we want our future to be, and we should continue to keep that conversation alive.
Margaret.
Security is the challenge, the critical challenge for our semiconductor design flows today. This is a topic we need to address in our design flows today. If you look at the great advancements we've made in automotive, autonomous systems, in health devices, it's amazing achievements, but at the center of all those achievements is the semiconductor chip. It is the device we must protect. Great comment. That protection starts early in the design phase. It touches on every key stage of the design, from developing a security architecture to that early analysis of the RTL, to monitoring that device after tape out in the system, and continue to have intrusion detection in order to keep our health devices, our automotive, our aerospace and defense, our national defense and critical infrastructure safe.
Okay, well, Mark, you had the final say.
So here's the thing, right? So I've been doing security for almost 20 years. There was a time that only few of us were doing microelectronic security. In 2007 and 8, I used to give talks in some companies. They would literally kick me out because they said, security, we have contracts. 2014 and 15, all sorts of programs in the area. 2018 and 19, DARPA and others started to invest a lot more, and then we got DoD programs with $1 billion investment. 2024, a lot of commercializations. You see the guys on here that they're doing a lot of security and transitioning cool technologies to the commercial world. So what happened? We went from zero market, $0, okay, market size, to as of today, based on our assessment in Caspia, security revenue, hardware security, and I'm only talking about chip level security. It's actually, based on our assessment, it's a $500 million market. 5 years from now, security is going to be a $5 billion market. If you look at the uptick actually happened in 2018 when Meltdown and Spectre happened, and thanks to Bloomberg's story, even if it was not true, it really brought a lot of attention to the issue. When we see another uptick with another big problem to happen, security market is going to go from 500 million to 5 billion.
It's only a matter of time.
Yep.
Well, thank you to our panelists. A round of applause for them. Thank you. And thank you to the audience.